Hello everyone, welcome back to the channel. So today we are doing lead code 1493, longest subarray of ones after deleting one element. And the good thing about this question is that the title in itself is actually pretty self-explanatory. We don't even need to look at what the problem statement is in this scenario in order to solve it. But still, just for the sake of you know not missing out on anything, it says given a binary array nums, you should delete one element from it. So this is given, no matter what the conditions are, you have to delete one element from nums. But then what are you trying to do? Why are you deleting one element from nums? What you need to do is return the size of the longest subarray containing only ones. So after deleting one element from nums, you are trying to find out the longest subarray containing only ones. All right. And if, for example, the array is filled with zeros, this can be a possible subarray, right? So return 0 if there is no such subarray. Now, if we take a look at the example test cases, and if we start thinking from a brute force approach, that would be, first of all, the first thought that comes up into my mind after looking at the test case is that I need to find out that particular 0 which has the most number of ones on its left side and the most number of ones on its right side. So comparatively, so there are, for example, let's say many zeros that you have, and you need to figure out that particular 0 which has the most number of ones on both of its side. So what I will do is I will simply traverse the array one by one, and for each 0, a brute force approach can be that for each 0, I am going to count how many ones do I have on the left side and how many ones do I have on the right side. Similarly, for this one as well, I'm going to count how many does it have on the left side and how many does it have on the right side. But you can very clearly observe that if, for example, let's take a look at what our constraints are. The constraints are 10 to the power 5, and what we are trying to do, in the worst case, it can go up to n square, because what I'm saying is, if I'm standing at this particular 0, I'm going to go and count these ones one by one, isn't it? So for this particular one, I'm doing 5. For this particular 0, I'm doing 5 iterations. Then for this particular 0, I'm going to do 1, 2, and then 3 iterations. So in the worst case, that can be up to O of n square. So we know 100% for sure that the brute force approach is not going to work. So the thing is, again, keeping in mind what we are trying to do, we are trying to find out a 0 which has the most number of ones on its left and right hand side. How can we do this? Now, since you and I are both experienced in lead code, we sort of know that whenever lead code says subarrays, finding out subarrays, the first thing that comes up into our mind, is the sliding window approach. So let's see if sliding window can help us in solving out these test cases that we have, this question that we have. So for example, let's say I have an I over here, I have a j over here. Okay, now what I will do is, since this is the first 0 that I'm encountering, I'll delete this one. Let's say I have a length variable over here, which is the ultimate length that, or you can say maximum length, that I have over here, and over here I have the current length. All right, now since this is a 0, I'll have a variable, let's say 0, which is initialized with false, right? I will mark it true such that I have found a 0. Perfect. I will increment my j and I will mark this true, that I have found my first 0, so that when the next 0 comes up, I know that, okay, I cannot have two zeros inside my subarrays. What I'm doing is I'm trying to delete the zeros, obviously, because I have to maximize the number of ones, right? You should also keep in mind there can be an array where there is no 0. So the answer in this case is not going to be 3, it's actually going to be 2, because just like I said, you have to delete one element from nums, no matter what nums is. You have to delete one thing from it, right? So what we are saying is we are simulating that we have erased this particular 0. I'm not going to count it inside my current length. All right, perfect. Then 1, 2, 3. So my current length becomes 3. Let's say this is initialized with 0. Okay, then I stumble upon this particular 0. I cannot have two elements that I'm erasing from the subarray, right? So what am I going to do? I'm going to increment this particular I pointer such that this 0 goes out of my window, right? And I'll subsequently be updating the maximum length as well. The current length that I have is 3, 1, 2, and 3, right? I will increment my j pointer, so current becomes 4, then increment, current becomes 5, then I get another 0, right? So the maximum length becomes 5, and now I will have to shrink my window again. Why? Because I cannot have two elements that I am deleting. I can only delete one element, right? So what I will do is I'll increment my I, increment my, or let's say something like this. My I was at this point, right? I increment my I, and I change the current from 5 to 4, right? Increment my I, change it to 3, increment again, change it to 2, and then since this is a 0, I'll just increment one more time so that this 0 goes out of the window, right? I won't, however, decrease the size of current, because the size of current represents how many ones I have in the current subarray, and not 0. 0 we ignore actually, right? Similarly, then I'll increment my j, the current length becomes 3, but I already have a better length, right? So this is how basically using sliding window we are able to very easily solve this particular problem, right? And just for the sake of it, let me erase all of this and let's test it over this test case as well, right? So for example, if I have my I over here, I have my j over here, right? Now current length is 0, this is 0, and this is also 0. 0 is false. I do not have seen, I'm still, I haven't seen any 0 up and until this point. Gets incremented. How am I going to calculate the current length is basically very simple, like this: j minus I at each and every step. Okay, so right now j minus I is what? 1. Perfect. I have 1 inside. I have this particular thing inside my current window. Again increment, j minus I becomes 2. Perfect. Then I have a 0. So what I will do is I will mark this as 1 such that I have seen a 0. Alright. But now if I calculate j minus, if I increment it and now I calculate j minus I, it's going to become 3. Or it doesn't, it shouldn't, right? It shouldn't, because this is a 0, this is not a 1. What I will do is I will also say minus 0 over here, so that when 0 is true, I am successfully able to sort of eliminate it from the size of my window, right? So yeah, in this scenario, although I have this particular window, but then this is being ignored because of this, right? Perfect. This is a 1, I will increment it to 3, right? Again 1, increment, increment, so on and so forth, right? This is a 0. Now what will I need to do is I will need to shrink my window. So what I will do is increment I, increment I, right? So since I have incremented I 2 times, this is going to become 2, and since this is a 0, I need to push it out of the window. I will increment my I one more last time. So as you can see, the current is 2 right now, and I have 2 ones inside my current window, right? Then again I will increment j, current becomes 3, so on and so forth. And one thing which I forgot to do actually was keep track of the max length, but then that I will be doing in each and every iteration, so you don't actually have to worry about max length. What I will say is, in each and every iteration I'll say, okay, calculate the length of the current number of runs that you have by j minus I minus 0, and then just update maximum length, something like this. So maximum of what it already is, maximum of what it already is, and the current length that you have. This I will be doing in each and every iteration, so I don't really have to worry about it. Now let's see if we are able to code this up into our coding environment. And what I will do is actually open them up side by side, right? So that we are able to successfully deal with it. Let's take an example over here. Let's say we have this particular example. Why not? 0 1 1 1 0 1 1 0 1. Sure. So just like we said, first of all, we are going to have I and j initialized to 0, and I will have a variable 0 which is initialized as false. And false can also be written as 0, right? So let me first of all make up all the variables that I have. So I have int n is equals to nums dot size. I have int I equals 0. I have int j equals 0. Then I have boolean 0 equals false. I could have taken it as an integer as well, but doesn't really make a difference. You can take it as an integer, right? And what else do I need? I need to calculate what the current length is initialized with 0 and the answer, or you can, yeah, sure, answer or max length is equals to 0. Then I will create a for loop. I will say while j is less than n, and why I'm saying j is less than n is because j is always in front of I. So if I is standing at one point, j is always is probably going to be ahead of it, right? Now the first thing that I do is I see what is standing at the current index. Let's say for a second that this wasn't a 0. Let's say that this was a 1. Let's assume for a second that this was a 1. So if this was a 1, what I simply do is I say, okay, if nums of j, if it's equal 1, just do nothing but just increment the position of j by 1. So what I'm really saying is increment j by 1, right? And then consequently what I do is I update the current length and the maximum length, right? So I will do that over here. I will say, okay, your current is equals to j minus I, right? Minus 0, but we'll come to that later. And ans is equal maximum length, or let's make it ans is equals to maximum of ans comma what the current value is. Let's call this answer. All right, perfect. Now we know for a fact that this wasn't actually a 1. This was a 0, right? So let's take that into account now. What I'm saying is, else if nums of j, if it's a 0, what I will do is check whether 0 is false or not. So if 0 is false, what I'll simply do is mark 0 as true, right? And include it over here. So if 0 is true, you do not have to count it in the current window. If 0 is true, do don't count it in the window size. All right, because that's not a 1. We are only interested in maximizing the subarray which only has 1. So we are simulating that we are ignoring the zeros, right? 0 is true, and I'll again do j plus plus. So I have marked the 0 as true, and I will increment my j pointer. Perfect. Now one, this is a 1, this is a 1, this is a 1, right? So my current is going to become 3, and then I stumble upon this particular 0. Now the thing is, if you think about it, there could have been a scenario, such that you had 1 1 0 1 1 0, for example, and your I was at this point, your j was at this point, right? So you came at this point, you marked the 0 as true, then you incremented your j, and then you came upon at this point. Now in the current example test case that we are talking about, where is it actually? um where is it? This one. 0 is at the very starting of the array, so I is already standing upon that 0, right? But there can be a scenario where the I is not at the current 0. So first of all, you will have to make sure that you reach the I. You will have to increment the I a couple number of times, right? In that scenario where you have already seen a 0. So I did see a 0 over here. I chose to ignore it, and I kept incrementing my j. So in that scenario, what I will say is, else if nums of j equal 0, and 0 is already true. First of all, make sure that you reach the 0, right? So I'm going to say nums of i uh, while nums of I is not equals to 0, sorry, while nums of I is not equals to 0, what you need to do is this: keep incrementing I. So what's going to happen is I is going to come up over here, and then I is going to come up over here, and then still I need to kick this 0 out of the window. So I'll just increment I one more time after the loop. Okay, so one more time after the loop, I plus plus. That is it. I'm calculating the current window size, I'm calculating the answer, and then over here what we will say is return answer. No, there can be a scenario where you don't have any one at all. So I'm going to check whether if 0 is false, if it's equals false, then that means you did not have even a single 0 inside of your subarray. In that scenario, I'm going to return ans minus 1. Why? Because at the end of the day, I'll have to delete, unfortunately, a single one, right? I have an array which is filled with one, so I'll have to delete one single one from them. Otherwise, just return what the answer is. So if I run it on the example test cases, let's see if it passes. It does not. I will probably have to include the check over here. I forgot to do it. Time limit exceeded. I am not incrementing j over here. I should have, right? Because j, no matter what the situation is, j gets incremented. And since actually I noticed I am incrementing j in all of these scenarios, I'm incrementing j in all of these scenarios, what I can do is I can just write j plus plus over here and remove it from here, here, and here actually, right? So I deliberately did not write this particular code, the refactored code, in front of you at the start, because that would have confused you a lot. So we started with a very simple, the very simplest way of solving the problem, and then we were able to refactor it into you know we were able to clean it up after we have done it, after we have done the basic part and achieved what we were trying to do, right? So it passes all the test cases. And if you think about what the time and space complexity for this code is, we are not taking any extra space, first of all. So that means we are taking O of 1 space, constant space. And if we think about the runtime complexity, that is very clearly O of n. Why? Because we are visiting each and every element that we have only once. So yeah, I hope you found the video helpful, and I will see you in the next one. Take care.